All right, we talked about atoms. We talked about isotopes. All right, we're going to this week get into something that we call electron configurations. What electron configuration is it's basically like each element's own fingerprint, because every element has its own distinct electron configuration. So when we're dealing with these electron configurations, they are based on these quantum numbers. So when we watched the video over quantum numbers, you should have got some things. And here are probably the most important things that I thought you should take away from that video. Quantum numbers. Okay? The first quantum number is what we call the principal quantum number. It describes the size of the orbital or the energy level of the atom. Go ahead and take out your periodic tables. Take out your periodic tables. Now, if you have the bigger periodic table, let's take the bigger periodic table out for now. Okay? The reason being is that the bigger periodic table already has these energy levels numbered. Look at the far left-hand side. Right beside hydrogen, to the left, you will see a number 1. Okay? Right beside lithium is a number 2. Right beside sodium is a number 3. Do you see where I'm talking about? Those are the principal energy levels. Okay? So they coincide with the 7 periods on the periodic table. So the principal energy level, the principal quantum number, which represents N, are those numbers right there. So if you would want to number right on your little periodic table 1 through 7 like that, that would be a great idea to do so. But that is the principal quantum number. It's signified by the lowercase letter n. So hydrogen would be on the first principal energy level. So hydrogen would have an N of 1. So would helium. The angular quantum number is also called the sublevels. This quantum number tells us the shape of the orbital. The shape of the orbital. And we'll talk about those in a little bit. Okay? Magnetic quantum number is lowercase m. It describes the orbital's orientation. And finally, the fourth one is the spin quantum number. And it describes whether that electron is spinning in the clockwise or counterclockwise direction. Now let's look at the principal quantum number, the very first one. Okay? It describes how far away the energy level or the electron shell is. The closer, the lower principal quantum numbers will be closer to the nucleus. So if you look, principal quantum number 1, which has hydrogen and helium on that energy level, are going to be very close to the nucleus. If we're talking in the energy level 7, it is further away from the nucleus. Okay? Which is basically what that says there. Now, the maximum number of electrons that can fit on an energy level is given by the formula 2n squared. You're going to need that. You're going to need that for some WebAssign stuff, and we will talk about that. Okay, we'll talk about that here later on. I don't think it will be today, but it will be when we go over electron configurations. Okay? So, the maximum number of electrons that can fit on that energy level. Now, if you look, the first energy level only has hydrogen and helium on it, right? So there's only 2 electrons on that energy level. Well, let's do the math here. What is N? N is 1, because it's the first energy level. What's 1 squared? 1, right? 1 squared is 1, times 2 is 2, all right? So let's look at the second energy level, okay? N is equal to 2. What's 2 squared? 2 squared is 4, times 2 is, there would be 8 electrons on the second energy level, okay? We could go on, but I think you get the gist of it, the math of it, okay? So what I have here, this little diagram, is just showing you basically some different, those are different S sublevels, and just showing you that, you know, N equals 1, N equals 2. So this would be the first, okay? This would be the first energy level. This would be the second. That would be the third. Okay? Now, at times you might hear these referred to as the PEL. You might see something PEL. What the PEL is just the principal energy level. And like I said, here are the different energy levels, and you should have those labeled now on your periodic table. Okay? The angular quantum number, which is also referred to what we call the sublevel. The sublevel, okay? It determines the shape of the orbital, whether it is an s orbital, a p orbital, d orbital, or f orbitals. Those are the 4 types of orbitals that you will be dealing with, s, p, d, and f. If you look here, and you don't have to memorize any of these, I just included this slide in here. These are what the orbitals look like. So this top one up here, that is an s orbital. It's a sphere. These are 3 different p orbitals. They look like they are kind of like dumbbells if I were going to talk about them. But as you can see here, okay, at times you will hear us talk about px. See how we have these grids here, the x, y, and the z? This is oriented right here through the x arrow, so that, or x arrow. So that would be the px orbital. Okay? Over here, if you look, this one's oriented through the y arrow, so that would be the py, and this one is up here to the pz. Okay, those are just the 3 different types of orientations of the P sublevel. Okay, notice that the P sublevel has 3 different types. S has 1, P is 3, D is 1, 2, 3, 4, 5, and F is 7. So 1, 3, 5, and 7. That's going to come in here in a bit. The magnetic quantum number tells us the orbitals. Okay? Tells us how many there are. We just said that, right? I just said that the P has 3 orbitals. The D has 5 orbitals. The F has 7 orbitals. And the S has 1 orbital. 2 electrons can fit per orbital. So the S can hold 2 electrons. The P has 3 different orbitals, so the P can hold how many electrons? 3 times 2 is 6. So there can be 6 electrons on the P orbitals. The D, I told you, the D has 5 orbitals. 5 times 2 is 10. Okay, 5 times 2 is 10, so D can hold 10. And F has 7 orbitals. 7 times 2 is 14, so it could be a total of 14 electrons on F orbitals. So we talked about right here, here is an S. Okay, the little yellow dots are just representing electrons here. So here is an S orbital that is a sphere, and it holds 2 electrons. Here are the different p orbitals. Okay, here's the px orbital, like I was saying. That is not very easy to read, but that says the py orbital. And here's the pz orbital. So you can see that each one of these orbitals has 2 electrons on it. Now, all this picture is right here is just all 3 of the p orbitals together. It's not separated into the px, the py, and the pz. Okay, so those p orbitals, okay, there are 3 of them. Each one holds 2 electrons. 3 times 2 is 6 total electrons. Now, the last quantum number we're going to talk about is the spin quantum number. And I told you that all this represents is whether it's spinning in the counterclockwise or the clockwise direction. And we just simply represent these as either being up arrows or down arrows. Either up arrows or down arrows, signifying that those electrons are spinning in different directions. And we will discuss these ways to draw these coming up later. Okay, so the number specifying the direction of the spin. Okay, and remember, this box right here just represents an orbital. So if this is hydrogen, this is an s orbital because it only has an s orbital. Okay, so the box represents the orbital and the arrow represents the spin. This is helium. Once again, it's an s orbital, but it's showing you, it's representing with the up arrow and the down arrow that those 2 electrons are spinning in different directions, in opposite directions.